This is a mnemonic, and it's hit or miss. If you like it, great. If you don't like this, don't worry about it. So the whale tail mnemonic. So bones can grow like us. Like as we grow older, we grow taller, and we kind of grow wider as well. So same with our bones. This is why our legs grow longer as we. But in terms of width, it's what we call appositional growth. So our bones actually start to build layers and layers of bone and start to open up more and more as we grow. So this is why a small kid won't have the same thickness bones as a fully formed adult. Now, interstitial growth, instead of growing thicker and thicker and thicker, what you have is that the bones are growing longer. So interstitial growth is along length. So this is one mnemonic is whale. So width, if your bone is growing in width, it's appositional growth. If it's growing along length, it's interstitial growth. Or the other mnemonic is tail. So thickness, if you get a bone gets thicker, it's appositional growth. If it's interstitial growth, it's growing longer in length. And it's so funny because like some students love this mnemonic because they just get it. Some don't. If you don't get it, don't feel bad because it's one of those hit or miss mnemonics. All right, so right here, so review, so epiphysis and diaphysis and metaphysis. Now, what do we have at the epiphyses? We have something called epiphyseal plates or growth plates. And what these are hyaline cartilage. And remember, for endochondral ossification, you need to set down hyaline first and then convert it to bone tissue. So why this is very important, especially in developing bodies, and maybe for some of our younger classmates here, is that your epiphyseal plates are why you grow taller as you age. So the cool thing is that these can grow until about 25 years old. Now, does this mean you'll complete? Now, it's not going to be a constant growth until 25 years old. But when I was in college, I was like, oh, there's still hope for me yet. But yeah, it didn't happen. Maybe I grew half an inch. But yeah, I don't think I grew half an inch. But supposedly, it's always continuing growing during your teenager years and young adult years. Some lucky ones may end up growing to 25 years old, or if you're like one of my aunts, she had puberty pretty late, like 18, so she probably was like growing until 25. But thing is that this is why we stopped growing. This hyaline cartilage isn't completely is like it runs out eventually, and when it's completely replaced, that's when we stop growing in terms of these long bones. So what we have remaining is something called the epiphyseal line. Yeah, so epiphyseal lines, here we have a growing, I wonder how old, maybe not teenager yet. But what you see is that, okay, review of x-rays, the denser something is on the x-ray, the more white it appears. But we see with these long bones is that we have this little chasm right here, this little dark line. So it doesn't mean that there's nothing there. It just means like this is a less dense structure than the surrounding bone. So that's actually where we find cartilage, these epiphyseal cartilage or growth plates. But when we're adults, what we notice is that we don't have that separation anymore. Eventually, the cartilage thins until we're left with these small little lines right here. And this is what we call the epiphyseal lines. So these are the remainders of what we had with these growth plates. Yeah, so compare this to here. Now these are completely fused, and there is a little line you can see on these long bones in the fingers here. And this is why. So we have all these chondrocytes over here. They're dividing, but the thing is that when these chondrocytes start to become calcified, they pretty much die off. They mature, die off, and they also become suffocated as well. So these chondrocytes, as their surrounding matrix is replaced by bone mineral, they die off, and eventually this process here outpaces the rate of division in this hyaline cartilage. This is why this gets smaller and smaller until we're just left with the epiphyseal line. Now back to our original question. Should children lift weights? And this is why it's very controversial, because they're growing and they still have these epiphyseal plates. And this epiphyseal plates, they're made out of cartilage, which is strong, but it's not as strong as bone. So hyaline cartilage is strong, but it's flexible. It's also prone to more stresses and trauma than fully formed bone. So is it safe for children to weight train? Well, here's the thing, like this is why it's very controversial for children who are still growing to weight train with heavy weights, is because they are worried about the growth plates being altered, the shape being, or growth plates being fractured, or if they become deformed, and that affecting the long-term growth and bone development of a developing child. So this is the main reason why it's a controversial topic, is because we want to make sure these children develop normally and their bones develop normally as well. So if we are trying to subject these relatively weaker hyaline cartilage to extreme stress, will that affect their growth long term? So I'm thing is that will we actually be able to answer this question? Well, the thing is that whenever you're doing a study in humans, it's like one of the things is that you don't want to have long-term harm to them. You don't say like, let's subject the test group to something and see if any harm comes to them. You actually can't get that approved by. You always have to get all humans, whether it's like a psychological study or doing a survey. Even if it's not, you can't have actually do intent knowing that there's an inherent risk of harming someone. And the other thing is that children are very protected by these studies. Like you have to make sure like pretty much everything is for the benefit of the child and you're not just finding out will this child get injured if they do this thing. So this is why it probably wouldn't be answered. It's more like how can if we do train children, how can we do it safely that we don't affect their long-term growth? So it would have to be very involved, very controlled studies. So you always have to, whenever you do a sort of human study, it has to be finding out something with minimal risk or some sort of benefit. So that's probably why we won't be able to solve that, or at least here in the US, because to do anything, and it's not just children. This is why, heck, during the vaccine, who were the last people to get it? Well, pregnant people and children. And why is that? They're actually, in terms of studies and human subjects, they're even more protected because, again, you don't want long-term damage or something happening to a woman or her developing child, or you don't want a developing child out of you who's like our little Lumpia deadlifter there having long-term effects. But yeah, so it can get more complicated as well. But yeah, this is why should children weight train? That probably won't be answered. Again, that's why growth plates are very important.